Hey everybody, it's Rick Husey at Z-Core. I'm here with Marty Kukul, and we will be starting here in just a moment talking about PON. Be right back. Hey, thanks for joining us for Tech Tuesday. Again, I'm here with Marty Kukul, sales engineer at Z-Core, and today we want to talk a little bit about PON and fiber because there's been a lot going on, a lot of buzz in the industry about different technologies. Everybody's hearing about 5G on the wireless side. That would be G like generation, but they say theoretically, I guess in a perfect world, could get up to 10G maybe as far as gigabits per second. And then we've got we had DOCSIS 3.1 come out, but now they're talking about DOCSIS 10G, and they're talking about gigabits. So they're trying to
absolutely.
So DOCSIS is trying to marketing-wise compete against a lot of the talk about 5G. And of course, a lot of this is the need for speed. It's people feeling that need for speed, and some of it is just a feeling.
Some of it is, yeah.
Some of it is marketing because the question is how much speed do people really need? But you're always trying to one-up the competition. So there's a lot of that going on. But there also are needs for speed because of more and more people streaming things and TVs like 4K and Ultra 4K that are coming out. So it's interesting that a lot of this emphasis on speed has been due to competing against fiber. So you've had fiber out there for a while, which was capable up to 10G kinds of speeds. So you had DOCSIS folks and now wireless trying to compete with that, and now there's new fiber technology. So that's what we're here to talk about today: is what is new in fiber. So that's my question for you. What are we seeing in fiber?
What we're seeing today is two technologies that have emerged since the GPON days. GPON itself was the ability to supply up to 2.5 gig downstream and about 1.25 gig upstream. As you said, because of the need for speed, as a lot of the consumers feel, and also because of the advent of video. Video is, like you mentioned, is probably the strongest driver of the speeds that are being put out there today. So with that said, we went from GPON to one technology called NG-PON1. NG-PON1 was basically your 10 gig service, and it also gave you the ability to different speeds upstream also. The only problem about that was that it kind of made or forced the hand of the service providers to invest into a lot more money into their network to accommodate that. So they looked for other ways of supplying faster speeds, and they came up with two technologies, XGS. XGS basically stands for X for 10, G for gig, and S for synchronous. So what you have is that you are able to get 10 gig synchronous, and it was motivated basically by the need for businesses. Hospitals and so forth that have a high bandwidth requirement, because of lab work and videos and so forth that drove that. They decided, well, we have the XGS, but that's still not a lot of speed that we're looking for. And so what evolved from that was a technology called NGPON2. And NGPON2 was more or less a continuance of NGPON1, except what you're able to do with NGPON2 is that you're able to lay up to 8 NGPON1s on top of each other. So instead of having the 10 gig on NGP1, you have 8 NGPON1s together on the NGPON2. So now you're able to get up to 80 gig subscriber traffic in your network. And that is both synchronous and asynchronous type of traffic.
Sounds almost like channel bonding.
It kind of is. It kind of is. But what you're doing is that you're using different frequencies now. On NGPON1, you were only held to 2 basic frequencies, and you couldn't overlap those frequencies. So what you're able to do with NG-PON2 is that you're able to use different frequencies by using tunable lasers, so that you can set up the frequency for each one of those NG-PON1 applications. So you don't have to worry about any type of overlappage, any type of interference, or anything that's going to, mess up your other frequencies, because you are able to tune into separate frequencies for each one of those NG-PON1 applications.
Mm-hmm. Is this using, I know in fiber they've had technologies where you can shoot the lasers down at different, and they can spiral down the cable, and they can do various things to help with speed. Is this that kind of technology? Are we there yet?
No, it really doesn't have anything to do with the type of laser or what it's doing whenever it's going down a pipe. What it really does is it just only separates that color, okay? Because whenever you're looking at light, you're looking at different frequencies. They're also associated to the light, okay? So now you're able to utilize different light frequencies to carry that traffic. And by what you basically mentioned before was, kind of like bonding. So that's what you're doing. You're putting together, again, up to 8 different types of platforms. But now each one of those platforms are running a different frequency, so you're not any type of interference. So by bonding all of them together, you get up to 8 NG-PON1s. You got 80 gig.
Okay. So we've got the XGS-PON and we got the NG-PON2. So what's the difference there? I think we actually have some.
Yeah. If you want, we have a quick slide that kind of shows you the differences here. The one on the left is the XGS-PON, and you can see, it was basically, put together in 2016. Okay, and it really was catered to the businesses, MDUs, and if you wanted to do some type of upgrade onto the GPON network. The bad thing about it is you only had 1 down and 1 up channel, okay, or frequency, okay? So you were tied to those frequencies. So in essence, you could not make it any bigger or any better because those frequencies were set, and that's all you had to play with. The throughput, as we can see, was 10 up, 10 down, or you could do it asynchronously by 10 gig down and 2.5 up, and you could also deviate or change the up speed by using different not different frequencies, but different applications, so that you could make it asynchronous instead of being synchronous. You can see the different wavelengths. They went from 1.577 nanometers and 1.27 nanometers up and down respectively. The big difference is with NG-PON2 is that it was really thought about before XGS-PON, even though it was deployed later. Okay.
Yeah.
And the NG-PON2 is really looked at for residential type of applications. Okay. With it, you can get up to 8 channels up and 8 channels down. So you're able to combine those channels together so that you can complete and make a total pipe of 80 gig because you're using the 10 gig from NG-PON1.
So they could theoretically then offer one subscriber up to 80 gig if they had a need for that.
If there was a need for that, yes, they could do that.
Does that, if they offer that to one subscriber, does that impact what they can offer to other subscribers?
No, because it is still just a PON. Okay, so whenever you're offering that package or that speed to that one customer, that belongs to that one customer. It's almost the same as whenever they were working with GPON, as we know today. You could offer a customer up to 1 gig worth of bandwidth into their household. But what you had to do is that you had to share that bandwidth, okay? And we're still doing it today, and it's being done by what is called dynamic bandwidth allocation. So all the traffic or all the pipe belongs to you, But if you're not using part of that pipe, it's going to take it and give it to somebody else. So that's how you get that 1 gig.
Okay. So is that handling the bandwidth back to the upstream provider? Is that what it's doing? Because you have to have a certain amount of bandwidth to the upstream provider to be able to offer 80
Absolutely.
gigs, let's say, right?
Yes.
So or is it on the network that you're actually dynamically assigning that bandwidth?
No, you're assigning that bandwidth on the subscriber itself.
Okay.
Okay. So whenever you're setting it up on a typical GPON type network, you're going to be customer A, customer Rick. How much bandwidth do you want? I want 1 gig. Why? I don't know, but I want 1 gig. And so that pipe going into your home through your ONT is going to be set up as a DBA type of application. So you're going to be given all this bandwidth, but if you're not using it, it's going to be taken away from you and given it to somebody else.
Or accessible by somebody else. Yeah. As
Exactly.
soon as I need it, I guess there it is.
There it is, right. If there's a need, it's there.
Okay. Let's see, I'm looking here, the wavelengths.
Yeah, and again, how this is all accomplished on the NG-PON2 is that the lasers themselves are tunable. So you don't have to concern yourself as what you would do on the XGS whenever you only have 2 wavelengths. You're able to have multiple wavelengths now on the NG-PON2 so that you can ensure that there's not going to be any type of interference or overlappage or anything like that that's going to cause any problems in the network by the traffic, overlapping or, collisions or anything like that.
And I saw where this is actually being deployed now. I saw where Verizon, I believe, was rolling it out with some Calix equipment. So
that is correct. Yes.
This is now reality.
This is reality. It is reality. And, it's just amazing because if you look at the date, we're looking at something that was thought about, basically deployed and approved 4 years ago.
Yeah.
It's taken 4 years for it to catch up to the equipment, the lasers, and that's what the prohibitive cost is anymore. It's not the equipment itself, it's the lasers. The lasers are very expensive whenever you're getting up into these high speeds.
So if somebody has a PON network today, just a GPON network, I guess the traditional thing that they would have had the last couple of years,
right?
Is this a forklift upgrade, or can they do parts of it in part of their network?
Yeah. Well, the network itself will stay the same. Okay, it's on the same principles. You're going to have glass, the fiber in place. You're going to have splitters in place, the PON splitters. The only thing that's going to change is going to be in the central office. You're going to have the NG-PON1 type of equipment. Okay, that's always going to be the base.
NG-PON1 is the base.
It is the base because what NG-PON2 does, it builds off of that NG-PON1. Okay. So you're going to have the NG-PON1 base in the central office, and you're also going to have the end user or your subscribers having the correct ONTs down there with the correct lasers, the tunable lasers, so they're able to achieve that high bandwidth.
So again, if you're trying to upgrade, it doesn't sound like you have to do it all at once. You can So you can put in the NG-PON1 in your central office.
Absolutely.
And you can still be serving your traditional GPON customers.
Absolutely. Yeah, and that's the big beauty about it is that there is nothing really huge that has to be done in the network itself because it's glass, it's fiber, and everything all depends upon the end devices. So if you have a typical GPON, 2.5 gig down, 1.25 gig up, you can ride that alongside the NG-PON2 traffic also. You don't have to make any major changes or any big development within the network to achieve that.
Okay, so it's just a matter of if you want to hit certain subscribers with this NG-PON2, you just have to swap out their
That's
ONT.
Exactly right. Yes.
So it's similar to DOCSIS in a way because they've got the HFC plant set up.
Absolutely.
Although I guess with DOCSIS 3.1, there's less and less coax and more fiber, I guess, right? Because right. More fiber deep. So,
oh yeah, yeah.
So there are challenges there if you're going from DOCSIS 3 to DOCSIS 3.1 and maybe having to extend out the fiber.
That's exactly right. Yeah, yeah. And it's like anything else. Whenever these service providers are looking at, okay, how am I going to achieve the speeds that everybody's looking for anymore? It has to be fiber. Okay, you can only do so much on the copper plant. And it's physics.
Yeah.
You know, there's nothing you can do. So fiber glass is the way that, you know, most service providers are starting to move to right now today.
Yeah, and I guess even on the DOCSIS side, they're putting more fiber in, but they're looking at the future maybe with the 10G and what they can do
Right.
there.
Yeah. Exactly. Exactly. Because, you know, it seems like about every 5 years there's some kind of new application that comes out that's going to just eat up your bandwidth.
Yeah.
You know, as you were discussing, you know, video. You know, that is the biggest hog right now when it comes down to eating up your bandwidth. You know, 4K, 26 meg. You have to have the big enough pipes in order to make it a good customer experience at the home, especially if you have one house that has 5 people living in it and all 5 people want to watch 4K TV at the same time, but different channels.
Yeah.
So it adds up.
Yeah, in fact, we were talking about that before we started here. We were like, isn't there some other TV technology that's coming out? And I think there is. I just couldn't find it real quick, but you know, we've got 4K out.
You're right.
You know, and not a lot of people have 4K, and there's not even that much content yet, I don't think. And they're talking about the next level of TV, which is going to be even more, require more bandwidth.
What we're seeing a lot more, though, is whenever we're doing the over-the-top, you know, whenever we're looking at, you know, YouTube, Netflix, they're starting to have more and more 4K programming that is going to be needed to accommodate, you know, in your home to have an enjoyable experience.
Yeah. And what is definitely starting to happen now is the cord cutting. I'm seeing that just both locally as people talk about that, you know, how they're now getting rid of their pay TV from their cable provider or their fiber provider even, you know, so they're dropping that and going with over the top. And for the cable operator or the fiber operator, a lot of times they're okay with that because they're still providing. You still need the bandwidth.
Exactly.
So, and it's expensive to provide video these days with the programming costs and costs going up. So I think a lot of times they're okay when somebody cuts the cord. They're actually
I agree.
Maybe encouraging that in some ways. Yeah.
Well, we're seeing it also that a lot of these service providers that were offering video services, they're starting to scale back. You know, because of the fact, like you're saying, it's very expensive. Yeah. You know, for them to provide video. So I think that they would rather be in the business of providing the pipes. Right. Yeah. Instead of the back end, head ends with all the equipment and all the maintenance and all the expenses. They're finding out that it's not worth it because more and more people are going onto the internet for their entertainment.
Yeah. Yeah, it used to have that pejorative term of dumb pipe. Nobody wanted to be a dumb pipe provider, but now I think they're starting to embrace that dumb pipe.
Absolutely.
It's a smart pipe if you're not having to deal with all of that. So I don't know, is there anything new other than, so we talked about what's kind of the reality now and what's coming out and being deployed. What's the next thing? You said it's like 4 years out.
It seems like it always is. Yeah,
so is there some other technology?
Well, I've been reading just only recently that they're experimenting with holographs.
Oh.
Okay, movies that would be projected in your room so that
you can walk around it.
The movie is in your room, or in your TV room or wherever it may be. It's not on a screen anymore. So whenever that starts to become viable, it's going to be a real big bandwidth hog because it's going to take a lot of bandwidth to achieve that. But that would be very, very interesting. Yeah.
Yeah, I really want a holodeck in my home. So I don't just want to watch it. I actually want to interact and be able to.
That would be cool.
Spar with somebody or something like that.
Yeah, absolutely. Why not? Do the Star Trek thing.
So what's coming down? Is there anything coming down the pike that would support that bandwidth? Let's say on the
not
fiber
right
side.
now.
So they're still experimental.
Yeah, that's all still experimental. Again, but it's coming. And the good thing about having fiber deployed right now by a service provider is that the infrastructure itself, the glass, the fiber, is not going to change. That's going to be there. Okay, that's going to be the medium. That's going to be, cover or carrying all that bandwidth. So it's all going to be dependent on what's going to be at the central office or at the the cable head end, and what's going to be at the customer's residence.
Mm-hmm.
That's going to determine what the speeds are going to be, because it's glass. You can the speed of light.
Yeah.
In essence. So you just have to have the right equipment at the locations to accommodate the speed of light.
Oh, great.
Yeah.
Okay. So I appreciate your time today. That's
Okay.
very, very educational. So there you have it. So what's new in PON and actually what's being deployed right now. So thanks for joining us for Tech Tuesday. If you like this video, go ahead and give us a thumbs up. You can always hit the subscribe button below the video to subscribe to our channel, and click the little bell icon. Ring that bell if you'd like to be notified whenever we're live with a video, or when we post some new recorded video. You'll be notified of that for sure if you click that little bell. So Marty, I appreciate it.
Okay, Rick. Hey,
And,
pleasure.
Yeah, we'll be back next Tuesday with Tech Tuesday. We'll see you then.